Hey there, welcome back to the tutorial on building a Simon game, a pattern reproduction game. What happens is that the game would choose a series of buttons to light up along with sounds to play for each button, and then it would play those and the player would have to reproduce the pattern. Each time they reproduced it correctly, the game would get slightly harder by introducing another button and speeding up or reducing the time between the button pushes or the sounds and the lighting up of each button. So the first time there might be two buttons pressed and there might be like, I don't know, a quarter of a second between the button presses. Second time might be three buttons pressed and it might be maybe 200 milliseconds between each button press, and then it might be four buttons. It would be four buttons pressed, and it might be 175 milliseconds between button presses. Anyway, you get the idea. It gets faster and faster, and the pattern gets larger and larger as the player gets things right. So what I'm trying to do here is run through my thinking on prototyping the game. The first thing I want to do is basically build out the game components, the kind of game mechanics, and see if I can't get them working and be able to get something up and running shortly that's testable, that can give us an idea of whether this is going to be fun or not, and whether there are little tweaks or little things that can be changed in the development process along the way that might make it more fun if it's not fun. Okay, so let's get back to where we were before. When we ended up last tutorial, we essentially had this set up. If I press twice quickly, we lose the original color of the button. We end up with 4 black buttons. So that's not fun. I can't continue to click on these things. So you can clearly see that we have a problem with our logic. So I'm going to go ahead and fix that right now by opening up our Simon button script. And eventually this Simon button script will be refactored into a new name. This Simon button doesn't really make sense, although we will need a button class. And I'll go through the thinking on how the game works and what kind of classes we need. So okay, so our script here essentially goes through and checks for the fire button being pressed, and if that's pressed, then it goes on and it creates a ray that shoots out from the camera in 2D space. It gets converted to 3D space through the screen point to ray function on the camera script. And then using the physics system, it checks to see whether it's collided with anything in 3D space. And if it has, then it runs through all this code here, which this code gets it gets a button component on our hit object. This really isn't necessary right now. We don't have any code for that. We don't have a script on our buttons that even deals with that. If you look back here, there's no button component there. I want to go ahead and just erase that for now. That's not important. Then it goes and it starts a coroutine here. The coroutine, like I mentioned in the last video, just fires off a method which has its own life. So this method here comes down here, it gets the original color of the button, then it switches the color to black. It waits for 1 second, and then it switches the color back to its original color. And if you think about it, the reason why our colors are our buttons, when we hit them too fast or just getting set to black, is because this coroutine is getting fired off twice before it ever finishes the first coroutine. So the first time it comes in, the material might be red for the red button. It saves that in the original color. Then it changes the color to black. It waits for 1 second, and then before it gets a chance to set the original color back to its material color property, it comes in here again because I've clicked on the button again. It gets its original color, sets it to black this time because the button is still black. It hasn't had a chance to go back to its original color. And then it sets its color again to black. It waits another second, and then it comes down here and it tries to set its color to the original color, which is, again, black. So what needs to happen is that this coroutine needs to be stopped before we start it. And we need a reference to our original color somewhere else. So, but a little bigger thinking, this Simon button really isn't a Simon button. What this is more of the player, because in the game Simon, the player is hitting the buttons. The buttons just respond to the player hitting the buttons. So in this case, this really could be called player. And we could have another script called button. So I'm going to go ahead and rename this to player. And I will go ahead and create a new script called button. And so now we've got a new script called button, and we've got this script called player. And I'll go ahead and add a game object here just for the sake of it to represent the player. I'll drag my player script over to that game object. And for the buttons, I'm going to go ahead and drop this button script on everything. So now what's going to happen is that the player will press on a button, and then the button will respond if it's pressed on. And the way that that's going to happen is that the player script, using most of the logic we already have here, using most of this logic, we'll just check to make sure, or we'll just check to get the component. So here we're going to get a button component from our hit object. Our hit dot transform dot get component button. So now we've gotten a reference to the button script on our hit object. This is assuming that the button is a button type, and we can do further checks by adding our buttons to layers, for example, or giving them tags. So a tag is a really good one. We can add a new tag called button, and then we can come up here and we can make sure all of our buttons are tagged as buttons. And then we can come back here and we can check to see if what we hit, if hit transform tag equals, we can say button, then we want to continue here. Then we know there will be a button component on that object that we just hit. We can keep this. This coroutine is something that's just meant for the button. So this is probably logic that we want to move into the button. So what we might want to do is we might want to say button dot activate, for example. We might just tell it to activate, or you can come up with another name implying that the button has been hit. Right now that's not important. What's important is that we have a method on this button. You can see the red underline, so I'm going to go ahead and control period. That's going to give me a recommendation that Visual Studio make this method. So I'm going to go ahead and start copying my logic over. So I just click on the method. I'll go back to my previous script. I just make sure my cursor's on the method, and then I can hit F12 and it'll take me right there. I can also right click on the method and say go to definition, and it'll take me right to the method that it created. So in here I might start this coroutine. For now, all I'm going to do is copy this logic in to the button. So you can kind of see what this is doing. This is making the button responsible for its own visual components. You can see that this is giving me a red squiggly because hit isn't a method. It's not a variable in this button. I really don't need to reference the transform. I can just say get component, render material. I'm still using the same change object color enumerator, so I can run a coroutine on this. Now I'll still have this logic error where the color could be wrong if you click too many times in too short a time span. So I'll go ahead and do that. Clean this up a little bit. Now you can see here what's happened. The player script is responsible for sending out any arrays, and then if it does hit something, that's under the button tag, then it goes ahead and fires off the activate method on that button, on the button script. It gets a reference to the button component on the button object that it hit, and then it tells the button to activate. And so this should still work the same way that we had it working before. There's nothing fundamentally different. It's just that the code has been separated into different classes here. So let's go ahead and see this in action. Okay, so now go ahead and hit each button. And you can see down here in the console, you can see I've still got the same debug log strings coming out there. We've hit an object, a yellow button. Someone pressed the fire button. So this is good. This is good stuff still. So now if I click twice, you can see it goes into that black mode where it gets stuck. So let's fix that next. So that logic now, it has been compartmentalized into the button script. So I'll go ahead and open that button script up. And there are lots of different ways to open it up. You can double click on the button slot in the button component there, or you can go down to your scripts directory, double click on the button. I like clicking on that slot over there a lot of times because it's usually open for me. But anyway, so let's try and examine this and see why this thing is turning black and not ever changing back to its original color. The fact that we're getting a reference to the color in here is a big indicator that we've got something wrong. We always want the color to go back to the original color that was determined at the beginning of the game. So really what we need is, not open that, we need a reference to a color. We'll just call this button color. And I can make this public so that the button color can be modified outside of this script. It can be modified in the editor. So I add this serialized field attribute, and that makes it visible and changeable in the editor. And then on start, so the life cycle of every component in Unity has an awake method and a start method that fires off before the update method fires off. There are a couple other methods that are important to know, like on enable and disable, on collision enter, on trigger enter, and exit. But right now we're just focusing on this start. We want to get the button color up front. So I'm going to say button color equals, and I want to get the material, which is part of the render component. How do I know that? Well, I can go ahead and look at, and I need to assign the color. I can go ahead and look at our button objects, and really any object that has a 3D mesh associated with it. You can see there's this mesh renderer, so that's a component, and there are a series of materials that can be assigned to a mesh renderer. In this case, material refers to the first material. So I'm pulling the material and I'm pulling the color property off of the material. And this is something that you learn over time through experience. The renderer has a lot more, actually I should say the material has a lot more ways, a lot more attributes that you can get a hold of. You can get color, you can get float, you can get integers, you can get all sorts of things from a material. You just have to make sure you know what properties you need to get, but there's some baked in properties that you can get without having to access the material itself that Unity provides. So like color is one of them, main texture is another one, the name, pass count, all these things. The render queue is a really useful one if you want to render objects on top of other objects. But for our purposes, we just need the color. So we're going to get the color here. It might be useful to also have an internal reference to the material so that we're not constantly saying get component if we ever need to refer back to the material. So I'm going to create a new variable, and then I'm going to say a material.color here, and I'm going to assign this variable just to the material, and then this variable gets assigned to the material.color. So now I can modify this script we can change the color to black, and then we can change the color back to our button color. So another thing that we'll want to do is stop a coroutine if it's currently firing off, because we don't want to stack a whole bunch of coroutines up to fire off one after another. So if I hit the button once and then twice before the button's finished going through its coroutine, then what's going to happen is it's going to change the color to black, and then it's going to wait. But then my next click would come through. It's going to change the color to black again, and it's going to wait. But after 1 second's up, it's going to change the color to my button color. And then after 2 seconds, it's going to try and change my color again to my button color. And that's unneeded. That's an unneeded call to the coroutine. So if I say stop, for now I'm going to say stop all coroutines. But if I want, and probably a safer way to do this is to create and we'll go ahead and do this now, a coroutine variable. And we can say coroutine equals start coroutine, and then we can say if the coroutine is not null, so it's not empty, then we can call stop coroutine and send in our coroutine. So now it checks if there's a coroutine running, then stop it. And then the next thing to do is to start a new coroutine. So that way we don't stack a bunch of coroutines on top of each other. So that's just a useful way of minimizing the amount of coroutines I could run. But it's always nice to stop your coroutines anyway, because there could be a lot of complex activity happening in the coroutines, and if they're still queued up and you're trying to run a new coroutine that does something that opposes the current coroutine, you'll find that your objects will do all sorts of weird things. You'll end up in a state where you don't really want to be. So let's go ahead and test this now. Hit play. Check that, check that, check that. Okay, so far so good. Let me double click. Double click. Double click. Okay, now like I said before, our game objects are set with, our script now has a color exposed in the editor. You can see I can select a new color. It's kind of nice. Unfortunately, so it looks like the color does get updated, but unfortunately the start color doesn't change until you actually update it once or twice. So right now the material starts from, the color is actually derived from the material, and then it's inserted into this color slot. What we probably want is the color slot to drive that material. So we can go back into our script, and instead of getting the color from the material, we're going to assign the button color to the material. Like that. And now our button color will drive the color of the material. So I've got black defined here. And it looks like I have black defined in all of these buttons. So everything's black. So that's great. So now let me go ahead and get the blue button, and I'll assign a blue material or a blue color to that button. The green button, I'll go ahead and do the same for each one of these actually. Let me see if I want like a nice vibrant green. It's going to look real nice. Let's go with the red. Nice blood red. Good. Alright, and the yellow. Let's get that yellow going. Alright. Great, so now let me hit play. And you can see we're back to having colors in our buttons. So we probably don't want these buttons to be black when you press them. So we could do a lot of things here. We could add a second color that we want our buttons to be. So we could make it possible that our buttons could fade. That would be another interesting thing. So if we had our buttons be semi-transparent on start, I'll just do this with one button, and then maybe when you press it, it becomes fully opaque. But so here's the yellow button, it's semi-transparent. Press it, it's fully opaque. So that's interesting. That's a technique that we can think of using in the future. Anyway, the colors aren't important right now, but what is important is that we have this whole system working properly now. So now we have, again, think about the architecture here. We've got a player script that's right here on this player object. It fires off a raycast into this scene, and if it collides with the button that's on a button tag, then it fires off its activate method. And I can show you easily if I remove this from the button tag. This is the blue button. My button does not get fired off. Nothing happens. Red button does work. So go ahead and add that back to the blue button tag. Go ahead and save this. It's been a little while. Save this. Okay, so we have some interesting behavior going on now. I'm going to go, say, another 10 minutes here, see how far I can get. But I think we've done some interesting things already. So another thing we want to do is we want to try and test out this Simon player. So I'm going to create a script for Simon. So what is the Simon player? If you think about it, Simon is the AI, right? And this AI is going to be fairly simple. All it's really going to do is select a series of buttons to choose from. And really, I can make this super simple. I can either just say that my buttons are 1 through 4, and I've got to pick a certain number of 1 through 4 integers. And then we can say that those integers represent each button. I could also just get direct references to each button and then save random choices. I'm going to start with just the integer selection. So in C# there's a nice generic array type called list. And this allows me to create an array that can grow and contract dynamically. So I'm going to go ahead and use that for my choices. I'm going to set that equal to a new list of integers. And just to get things started here, this is where it can get a little tricky. Unity has a random class, and C# also has a random class. So in order to choose my Unity class, I've got to reference the Unity engine here. And I'm going to start just by testing out the random engine, the random Unity generator, and just debug log it. So I'm going to create a new integer, and I'm going to call it random number. And I'm going to say Unity engine dot, let's type that, engine dot random. And I can do random range. I can pick between numbers, so I want to pick between 1 and 4. And then I'll just debug that. Debug log random number. Go ahead and save that. Come down here. And I'm going to get in the console. And go ahead and hit play. So I've got clear on play here. So interestingly, nothing showed up. Why did nothing show up? Nothing showed up because I don't have a Simon player. I don't have a script in here for Simon. That script that I just wrote is not going to fire off. So let's go ahead and drop that in there. Eventually, it makes sense to organize these into directories instead of just having them all in one directory. And I've got this I button, this button component. I think I was just testing things. Neither of those two are important scripts. If we need to, we can build an interface for the button, but that's not important right now. So now I've got Simon in the game. I could create a game object called players, and then I could just drop my 2 players in that game object. So those are my 2 players. Okay, so Simon now is in the game, and he should work. So I'll go back to the console, I'll hit play. We should see, we don't see anything right now. Let's go back here, debug log, random number. We didn't save our script. Here we go. So let's try this again. Go ahead and hit play. So Simon picked 1. Let's stop, we'll play again. Simon picked 3. See, each time I pick play, you can see I've got a new number. Picked 1, picked 3, and 0, picked 4. So if we want to see some more randomness in action, we can speed this up by throwing this random number into the update cycle of Unity. So I'm going to go ahead and do that. I'm going to create a new, call my random number, and I'll create a reference variable out here, and I'll make sure that this is not generating a new random number. Okay, so now we should see the spam. Actually, we don't really need this here. We should see this spam our console log. So let's go ahead and hit play. Boom, 1, 3, 3, 1. So it's actually going between 1 and 4. It's choosing 1, but I don't see it ever choosing 4. So that could be a problem. May not be inclusive. So we could do 0 through 4. Let's see, random range. It says max exclusive and min inclusive. So you can see that if I wanted to be 1 through 4, I can just do 5. It might be better to do 0 through 4 because most arrays, well, all arrays are 0 based. So this will give us a 0 through 4 number. So 0 through 4. 0 through 3, I'm sorry. So you can see that's picking 4 numbers. If I were to just add this number, add 1 to the number, then we would see the numbers that we need, or that we assume. What's this? So there we go, 0. Well, it's not adding because you can't add. Why is that? I just did +1 there. Now that +1 I just added there is just for visual purposes in the console here. Ultimately, we don't want that +1. So there we go. So now what we probably want, instead of having Simon just randomly choosing a series of numbers, what we probably want is to expose a class that the game can call to have Simon take his turn. So we can create a public and maybe return an array of integers and take turn. And maybe we send in the number of choices that Simon needs to make. So that'll be an integer. Number of choices. Just keep this as humanly legible as possible. So right now you can see the take turn is got a red underline. The reason it's got that red underline is because it expects a return value, and that return value should be an array of integers. So in here I'm going to create a new array of integers. It's going to be choices, and it's going to equal a new int number of choices. So I'm going to return my choices. So now our red line is gone. We're happy there. Now what we want to do is we want to run through a loop, which is the number of choices in length. And each time we're going to pick a random number. So I'm going to say for int I equals 0, while I is less than number of choices I plus plus. So I'm incrementing I. I'm going to say choices I equals, and then I'm going to pick a random number there. So I'm going to grab that random number generator that we have, remove that +1. We can go ahead and just get rid of that. So you can see now I should have a series of random choices there. I could debug log this and expose my choices and say Simon chose the following numbers. So there we go. So now I need someone to call this take turn. And actually I'll do this right inside Simon. I'll have Simon take his own turn over and over. Take turn. I'm going to just tell him to pick 4 numbers. And we'll just see what he spits out here. Okay, go Simon. So you can see it's actually not showing me the integers because they're in an array. And Unity doesn't know how to display those array variables without me telling it explicitly how to do that. So I could run through another for loop. And you know what, instead of doing that, I'll just copy this. Now if you just do Control-C over a line, it automatically copies it. And if you do Shift-Delete, it deletes an entire line. Another interesting thing. So I'll do choices I. So I could create a string here and then debug log the entire string after that, which might look better. Why don't I go ahead and do that? Debug log output string. And I'll just do string output string. And this will all get deleted because we won't need this. If we were to need this, or if we were to need to display what buttons Simon was choosing in our game, we could easily use a string to help create something like that. So I'm going to do a plus equals to concatenate our string. I'm going to add a comma and a space before each choice. And really I want the first choice in here without a comma in front of it, so I'm going to say choices 0 here, and I'll start this at 1. And this needs to be a string, just like these need to be a string. So there we go. So that's a little more complicated, but all I'm doing here is I'm just assigning the array values to a string, and then I'm logging the string to the console so that we can see all the choices that Simon's making. So again, he's going to choose 4 numbers. And they should all be random numbers. So there we go. So I'm going to go ahead and pause that. We can look through some of these numbers. So you can imagine maybe we're going through the buttons. Maybe the blue button is 1, the red button's 2, the green button's 3, or the blue button's 0, then 1, 2, 3. So you can see here Simon's picking 1, 2, 0, 1, 0, 0, 0, 2. So these are somewhat random numbers here. Looks good to me. Looks like something we can use. Eventually we might see that we need to assign a seed to the Unity random method so that it chooses different random numbers every time the game starts, although I'm not sure, maybe the Unity random method already uses a random seed. But that's not important right now. What is important is that we can see Simon now has a mind of his own. He chooses random numbers. What we will want to see, and this will be part of the game class, is the ability to tell Simon to choose more numbers. And I can easily do that inside of Simon. Int number of choices equals, we'll say 1 to start with. Actually, let's start with 2. 1 is pretty lame. So number of choices, and then I'm going to add a plus plus here. Now, this is going to get really harrowing, but basically what's happening here is every time it calls take turn, it calls take turn with the number of choices. The first time it's 2. And then what happens is that this plus plus at the end will increment this number by 1 after this line. So the next time it comes in, it'll choose 3 numbers. So Simon will eventually choose hundreds or thousands of numbers. And we won't want that because nobody will ever remember that many numbers. But we do have the ability to choose more numbers here. So you can see, boom, quickly it grows out of control. But you can see here we've given Simon the ability to think a little bit and to choose more and more numbers. And it'll be interesting to see how many people can actually remember a sequence of these numbers once it gets, I don't know, 4 or 5 levels deep. You know, once you get to like 10 numbers or 12 numbers, it's got to be pretty interesting. People who can remember that many numbers, I'd say, are pretty interesting. I certainly can't. Anyway, so there we go. We've got our functionality here for Simon to be able to choose more numbers. He's not exactly a genius, but that's helpful. Now, one interesting thing here is that we might want to keep this code around, but we probably don't want to keep it in the take turn method. So we can refactor this. Previous versions of Visual Studio or Pro versions give you the ability to just refactor segments of code, and there probably is a way to do that. In this version of Visual Studio, this is a free version, it's Visual Studio Community, but I don't know exactly where it is. I'm going to go ahead and just cut that out. I'm going to say log choices and send in choices. And I'll go ahead and hit Control period. It'll create a method for me. Come down here, I'll just put all the code in there, and that's it. So now I don't need to worry about all the code that's in here, and I can say if we're in debug mode, and log that. I can add a new serialize field. Serialize field. Boolean debug mode equals false. So we'll start off with the premise that we're not debugging. And I can come into Simon, see that debug mode, hit play now. Nothing is output. Do that. You can see there's all sorts of errors output. Why are there errors output? So there are errors output because it's taking in choices, index out of range. So number of choices is growing before. So really we want well, let's not worry about this right now. Not important. We'll just leave this off for now. We'll fix this later. But ultimately what's happening is that the choices is growing. Well, okay, we can fix this real quick. We'll just say number of choices. We'll send that in. Say number of choices. And now, even though this variable is a variable that's defined in the global scope of this class, defining it here in the local scope takes precedence. Ultimately, I think it makes more sense to use a different name so you don't confuse these. So we could just call this num or total or something else. But you're in a different scope, and the scope here would overrule the external scope unless you use the this prefix. So there you go. Now I can turn it on and off and leave it on here. Let me see. There we go. Okay, so I'm going to leave it there for now. So what we've done so far is prototype Simon the player. We've developed the player script, which right now just allows you to pick buttons. It doesn't actually save any of your choices. Turn off that debug here. It doesn't save or submit any of your choices to anything. What we would need next is a game script. And that game script is what controls the rules of Simon. So the game script would basically tell Simon to choose a certain number of buttons to play, and then it would play them. And then it would wait for the player to choose that same pattern. And every time the player presses a button, it would log that button, compare it to the current slot in Simon's pattern, and see if they're equal. If they're not equal, then we'd play some kind of sad trombone or some other sound so the player knows that they just made a mistake, and then it would start over. Next time Simon would pick 2 colors to start with, and it would play those colors or play those buttons. So we'll go ahead and work on that in the next video. So I hope this was informative, and I hope it was helpful. I hope somebody's getting some useful information out of it. But so far everything feels pretty good. I feel like we've been able to test Simon, we've been able to develop the player, we've been able to get our buttons to work. So we're making good progress. All right, until the next time.